All right, so picking back up from where we left off last month on this last class, fluid power motors. So these convert fluid energy into rotational mechanical energy with an unlimited stroke. You've dealt with these a little bit in lab, right? Just by adding air to the motor, you were able to make it spin perpetually, right? So displacement is the amount of oil or air that must be pumped into the motor to turn it one revolution. Most of motors are fixed displacement. However, they do have some that are variable displacement. And they are, and of course, they are either unidirectional or bidirectional. They are not three-directional, by the way. They either go one direction or they can go two directions. They cannot go any other way. Okay, there we go. So these should look familiar. These you can find in the fluid power book. I think page 1, 2. So there you saw the symbols for a motor. You have unidirectional versus bidirectional. By the way, guys, anybody remember what the arrow through it means? That something is what? Variable. Thank you. You have ones that are pressure compensated. By the way, what does it mean to be hydraulic versus pneumatic? You have the colored in triangle versus the clear triangle. Clear is pneumatic, colored is hydraulic. Clear is being air, hydraulic is, you know, and if you've ever seen hydraulic fluid, it's not clear. Unlike gasoline, which for some reason is clear. Which, considering what crude oil looks like, you have to wonder how they get gasoline to be clear. Because if you've ever seen crude oil, that stuff is just sludge. It is. Yeah. All right, so you have a gear motor, which, and we're going to talk about a little bit more about each of these. You have vane motors, you have piston motors. We used to have a couple of these. One of them has disappeared. I don't know where it has gone to. So external gear motors, these have two meshing gears. One gear is connected to the output shaft, and you have an input port. So this is a gear motor. And we actually have one over there. It's the tannish grayish thing. You can mess with it later if y'all want to. Okay, so you have your system operating pressure coming in. It spins the two gears and it exits the other side. Okay. So it comes in, it spins the gears, and it goes out the other side. Fairly easy, right? So this is the way an external gear motor looks like. And then you have the internal gear motor, which is a single inner gear that has one less tooth than the outer gear. You have a direct drive or an orbiting. I can't tell if they meant to put gear rotor or just rotor. That is an interesting, huh? I don't know what a gerotor. Gerotor? Is that an actual thing? Didn't think it was. Somebody put it in there. I think it is supposed to be a rotating gear or gear rotating, something like that. So do y'all know what direct drive means? Anybody? It means it's directly engaged. It is itself what's spinning whatever's going on. Yes.
Oh no, actually, that's how this is actually a thing.
Really?
Hmm.
Hmm.
Yeah.
Okay. Well, I guess it is called a gerotor. Strange word. So the way this works is as the fluid comes in, this thing is spinning one way. Okay. You have the pressure coming in here and it has less pressure on the output line. So thus it is spinning towards the output line. Just like anything in a system, you always go from high pressure to low pressure, right? Thing about electricity, you go from high pressure to low pressure, right? Same thing for anything to do with a motor or any other such things. It's looking for a way to get it from high pressure to low pressure. That's what causes that push. That's what causes the spin. Okay? So you always have pressure in, pressure out. Um, and then you have your shaft right here, which is going to be outside of this, and that is what is causing the spin. Again, this is a direct drive, so this is going to be mechanically connected. This right here is going to be mechanically connected to whatever it's driving. Does that make sense? So this is actually the piece that is rotating. Yeah. You have what's called a vane motor. This is quite a common one as well. Um, it just does not have as much displacement that you have to work at. It's got essentially a, I am reaching for words tonight for some reason. I have to excuse me. So the way a vane motor works is that these wipers, essentially, the way these are working is as they move through, they can extend and retract depending upon how much space there is between one wall and itself. But the whole purpose is to keep that fluid moving. Does that make sense? But it just is a way to keep fluid moving. All right. So inlet pressure is always higher than outlet pressure, which is what causes everything to continually move. That is all hydraulic and pneumatic pressure, right? That's the easiest way to know that how any motor works is that it's all dependent upon inlet pressure and outlet pressure. Inlet pressure is always greater than outlet pressure. Um, and then we have a piston motor, which we actually used to have one of these. I don't know where it's gone. It disappeared. It was the giant yellow thing that was sitting on this table a couple weeks ago. It was sitting on this table over here. Okay. And you could actually grab hold of it, spin it, and actually see how it worked better. Anyway, I can describe it to you. But you have a piston A and a piston B. And as they move through the rotation, the fluid compresses and releases. Okay. All right. So we'll leave that as the motors, and we'll go ahead and move to the next one, which is actual systems. So these are some older style compressors. It should be labeled as pneumatic hydraulic systems. So these are some older style compressors. So compressors come in several different ways. Okay. you can either have a little single stage compressor, like I said, you can have those at a job site, or you can just have them on hand. If you think, I'm trying to speak too fast right now for some reason. How many of you have a tire inflator that you keep in your car for if you have a flat tire? Nobody? One person? Do I even know what I'm talking about? It's just these tiny little compressors that if your tire goes flat, you plug it into your car and it goes to town and blows your tire back up. You know what I'm talking about now? Okay. You cut compressors from that little thing all the way up to compressors that are able to work a whole factory. And technology is constantly always improving with these. The ones you will generally find at work are the ones that have big tanks. Why? Because that gives us a reservoir to hold pressure. If you have something like a job site you've got to go to, those don't always come with a tank. They're nice when they come with a tank, but they don't always come with a tank. Okay. So you have several different types, and we'll talk about these. You have the reciprocating, which if you've ever seen a reciprocating motor, kind of just works exactly like the motor in your car, back and forth, back and forth. Rotary screw, your sliding vane, impeller, liquid ring or liquid piston, diaphragm, and centrifugal. So motor displacement is the amount of fluid that moves through the device in one revolution. Compressors and pumps, this is per a minute. All right, that's why we have CFM, which stands for what? Cubic feet per minute. And then you have GPM, which is gallons per minute. So positive displacement is a compressor in which the gas is entrapped in a space and the space is reduced, increasing the pressure. So in other words, if you take a bottle and you start trying to crush it, what have you done to the inside of the bottle? You've increased the air pressure, right? The pressure has increased inside the bottle. Not always by a bunch, but by just enough that sometimes it can pop the cap off, right? Anybody ever decided, weirdly enough, to put a empty water bottle full of air on the concrete and then step on it? Pop the cap off. Just for fun, right? Kind of an interesting experiment in pneumatics. So displacement is measured in cubic inches per revolution or cubic centimeters per revolution. Centimeters being for metric, inches for imperial. Okay? So you have single stage compressors with only one, where you have one or more cylinders with the same bore. Multi-stage compressors, these are very, very common. This is where one compressor feeding into another compressor has a smaller displacement. You have a single acting compressor. These compress when the piston moves in one direction. Double acting compressor when it moves in both directions. The ones in your car, what kind of pistons do we use? This would be a single acting. Why? Because it moves in one direction. Whenever it moves in the other, it's sucking in gasoline and air, because the only way a combustion engine works is by mixing gasoline and air to the correct ratio, so that whenever it starts compressing it up to where that spark plug is and it ignites, it's able to take all the pressure and push it out of the exhaust, which is pretty much how you get the power out of your car. Very basic internal combustion engine. This works very similar to that for single acting. For single acting, what it's doing is basically pulling it in, compressing it until it's compressed it as much as it can before it forces the valve open and it pushes it out. Only this is doing it far faster than what you think it is. Double acting is doing it on both ends of the stroke. It's doing on the in stroke and the out stroke. We've talked a little bit about intercoolers. This is cooling the air between the stages. Why? Because think about it this way. What happens as you compress anything? Well, what happens to molecules? Molecules become what? In any fluid, I don't care if it's air or if it is a liquid. Y'all remember your basic molecule lessons on those? So for air, all right, so for any fluid, you have molecules, right? For fluid, they tend to hang out fairly close to each other, right? Just enough that they're there, right? Air, they don't really want to know each other, right? I can see you over there, but I don't want you anywhere near me. That's air. What happens when I start pushing these molecules together with compression? They're trying to push back, but they'll also start doing what with their fellow molecules? They become closer together, right? And the closer you get them, the more excited they get. Because what's on the outside of these molecules are electrons. Okay? So the more it works, the more it gets restless, the more restless it gets, the more heat you're going to generate. Why? Because the molecules, instead of being, I'll put it to you this way. If you took 50 people out to a park, a really nice big park, right? They're all running around happy. They're free to be them, right? Take those same 50 people and put them in a small room. What happens? If you're one of those 50 people and you are crammed next to all the rest of your people, what are you going to start doing? You're going to start pushing and shoving, getting mad, wanting your space. You're going to build up. And what happens to the temperature of the room? It's going to get hotter because what? More body heat. With molecules, think about what's happening if you're one of those 50 people in that room. You're going to start bumping into people, right? Guess what that generates? Of more friction, which is also heat, right? So you're bumping into each other, you're generating more heat, and over time you just get to the point where you generate a lot of heat. Why is heat the enemy of any system? Wear and tear breaks things down that much faster, right? If nothing else, you and those same 50 people are going to try and start breaking down that door, right? Because you want out of the room. The heat is going to cause stress, and the more stress things have, the easier they break, right? Same thing for air. Same thing for any fluid power. The movement of those molecules is being confined, right? So as they get closer to each other, they're going to start going, I can't move. I can't move without touching somebody. So thus, you're going to end up with friction. The more friction you have, the more heat you have generated. In order to prevent damage later, a lot of the time you want something to cause it to cool down. You want to keep the compression. You want to keep the 50 people in the room. But what would you do to keep them happier? You would crank the AC, right? Keep everybody from overheating. Because the hotter people are, the more, thank you, aggravated. The aggravated is a good word. There's a lot of other words I could think of, but none of them were as appropriate as aggravated. Seriously, you stick 50 people in a small room, they are not going to be happy. The hotter they are, the even more unhappy they are. However, if you crank that AC to where it makes it nice and cool in the room, all of a sudden it's not so bad, right? You still have the ability to talk to your fellow human being instead of, if you touch me again, I'm going to insert threat there, right? So intercoolers and aftercoolers are a marvelous thing to have because these cool the air at either between the stages or at the final stage of compression. In other words, after you stick all 50 people in the room for about 10 minutes and they are all getting aggravated, you crank the AC as it comes out. Or you crank the AC as you throw all the people in and everybody's a little bit easier to deal with. Does it make sense? So with reciprocating compressors, you have a single acting, double acting, single stage, multi-stage. We'll talk about some of these. So this is a reciprocating compressor. It looks a little bit like something else. Anybody ever studied the internal combustion engine? Is this not what your engine in your car does? Okay, this is doing the exact same thing. What it's doing is pulling in air, compressing it, send it to the next one, let it compress it more, send it to the next one, compresses more, send it to the last one, compresses more, and then it's done. Reciprocating, what does that mean? Well, it's moving back and forth. That is the definition of reciprocation, right? Okay. Yes, it is going from right to left in this particular case. That is not always the case. It depends upon how it's set up. So if you look, what it's showing you, all right, it's showing you that the air comes in. I wish I could slow this thing down, but I can't. Watch the arrows pop up. It shows it coming in here first and out of here, in here, out here, so on and so forth. But it just keeps moving. All it's really doing is moving the air from one place to another. So this is a single acting, single stage compressor. So this is something you would see on a job site, right? Why? Because this would be very easy to drag onto the job site to power your pneumatic air tools. Something like a pneumatic nail gun or a pneumatic hammer. Why? Because you don't want to have to do that by hand, right? Because who wants to sit there and have to take each nail or each staple and go bang, 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 bang? Have to nail them in individually when you can take a air tool and go, just keep going. All you gotta do is have that trigger pulled. Y'all know what I mean? Ever use a pneumatic nailer or pneumatic stapler? Those things are fun. Just make sure you keep your fingers and toes and other appendages from other people out of the way, and you are fine. Yes, but I put it to you this way. My dad was helping to build our old house, all by himself. He was in there putting up some shelving. All it ever takes is one moment of inattention, and you can hurt yourself pretty badly. I think he's nailed himself more than a couple of times. Why? Because he gets distracted, and I mean, I can tell you right now, all it ever takes is just a little bit of distraction, and you can take out your own appendage. Okay? I personally, uh, I have been learning how to do metal stamping. And one of the things I've gotten a hold of is a texturing hammer and some bracelet blanks. And it's been fun. Up until I started playing with my texturing hammers. And instead of doing what I normally do, where I tape the bracelet to my steel block to make sure it does not move, I had a hold of it with my hand. And my finger happened to get in the way because I got distracted. Oh, lesson very learned, because that has taken several months to grow out. Yeah, and it's been really fun to watch it and have everybody give me the advice of, you need to poke a hole through it. No, let it grow out. It will not kill me. Far worse things could happen, you know? Far worse things can happen than just allowing it to be growed out. Okay? And this is a single stage compression. I don't know why I did such a short video, but there you go. All it's doing is sucking air in and compressing it as it strokes through. So single acting, single stage, two piston compression, which is what we just saw. Just keeps moving the air through. Double acting pulls it from both sides. No, not really. It can be. See if this will pull up that video real quick. Just a little animated video for y'all to look at. So it pulls on one side, compresses, pulls the other side as it compresses. So this is a double acting compression. So it's compressing on both runs of this. Does that make sense? When it's pulling in cool air. Whenever it's compressing, it's pushing out warmer air. Why? Because you have forced those molecules together, and what happens when you force them together? You create heat and friction. But you're getting compression on both ends of this. Okay? This is why this is known as a double acting compressor or compression. All right. All right, so this is a single acting two stage. Okay. And this one actually has an intercooler. So what would we say the intercooler was for? Cool it down between stages, because the last thing you want is a lot of heat built up in your system. Right? This is a single acting two stage. So you have one central piston moving everything. You have the larger piston, which is pulling things in and going ahead and doing compression first, and then it moves to a smaller space. So this would be like taking a 2-liter bottle, compressing everything in it, moving it to a 500 milliliter bottle, a lot smaller, and being able to compress it again. You're going to get a lot of force out of that, right? Some videos to go with this. Pull this over. All right. So just another little video to show you the different ways that these are working. Now, why would we choose one over the other is always going to be dependent upon what? What you're using it for. What are your actual needs? Am I going to get, how many of y'all have been to Ethel Hall and seen the big compressor that's back in that room? That thing is huge, right? I'll show, if you haven't seen it, you can always come by and see it. It is a very big compressor. Why do we have such a big compressor for that? Well, because originally the 4 classrooms on the bottom floor of Ethel Hall were all automotive. And in automotive, what do you use? You use a lot of air tools, right? You use hydraulics and pneumatics a lot with automotive, right? Air tools, hydraulic lifts, all that kind of thing. So in other words, you need to volumetrically have quite a bit of air being able to be moved at any one time, yeah? So you make a bigger compressor to do the job. And so you make sure that that compressor is sized appropriately. That is what you should always consider with anything you're having to use, is what are my actual physical needs going to be, and what do I actually need from this? Does that make sense? I mean, this is true with any job, with anything you ever do. What is my actual needs and what am I going to do with this? I don't care if you're buying a car, if you're buying equipment for work, or what have you, it's always about what are your actual needs. It never hurts to slightly oversize, but getting one, put it this way, if you get a giant compressor for your house, you might want to make sure you actually need it instead of just getting a smaller one. You don't want to carry around a air compressor the size of your car just to fill up a tire, right? That's all I'm gonna say. So this is one that is a 2-stage with an aftercooler and intercooler as well, apparently. So they're pointing that out. So this one's a 3-stage compressor. Again, this is all about how much pressure do you actually need. The higher the pressure you need, the more you're going to have to work at it. This one's a multi-stage. Very pretty, isn't it? Looks very efficient. This one's all sorts of different ones. Now, what would be the difference between one that stands vertically and one that lays horizontally? You can have tank size as one thing that can be different. Lower ceilings. Now, one of the things you might have a problem with the ones on its side is what? Huh? Throw it in your truck. But one of the biggest problems you can have with the ones that lay on their side is that they can build up more what? They can build up more water. They can build up more liquid over time. Well, the more you compress air, the more you're going to bring molecules like hydrogen and oxygen together. And if they actually start to bond, they can become bihydrogen oxide, water. Yep, the stand-up ones have a point they go down to, and they have a drain to them. Yep. Yep. The ones that lay on their side have the ability to accumulate a lot more fluid than the ones that stand vertically. The ones that stand vertically come down to smaller areas than the bigger ones, and you can drain them much more easily. You need to drain them frequently. Why? Especially here in the South, because in summer, your humidity is just terrible. You have a lot more hydrogen and oxygen in the air than normal. Oh yeah, if you don't do it regularly, you're going to rust out your everything. You're gonna have a lot of issues. So needs are a thing to consider, space and everything. Um, no one is better, truly better than the other. Just always depends on what you need. But one of the things you might want to consider when you're getting any of this is how are you going to drain it, right? Because you need to drain it periodically. I would say at least once a year. You need to make sure you pull all that nasty stuff that's in there out. Probably want to do it maybe once a month, or you might have an automatic shut drain off elsewhere in your system to pull all that water out of there. You have to hook it up to automatically drain, like putting timers and stuff like that on it. That's up to you as the owner and or operator. Mm-hmm.
As soon as you close it off, it just pops open. And granted, that's the point of failure, but if you forget to drain it, it don't.
All right, so going back to talking about sliding vane, this is a far better viewing of it. We used to have one. I don't know where it went. It has disappeared along with a couple other my display pieces apparently. Which why anybody would want those display pieces, I can't fathom. But these could be single stage or two stage. Single stage gives you a pressure of up to 50 psi. Two stage can be 120. And these have a capacity of up to 4,000 cubic feet per minute. You can see the way these work. Here is your area that your fluid travels in. It narrows at one end, expands at the other. The veins have the ability to slide in and out as they move, allowing you to expand your area and then retract the area. Does that make sense? So that no matter what, you've got a good seal. Just put it that way. You have a good seal. Okay. You also have what's called the rotary screw. Again, all of this is going to depend upon your needs. Single stage is 50 psi, two stage is 150. You have between 120 and 4,000 cubic feet per minute. So what the rotary screw does, you can kind of see, it narrows at one end and it's expanded at the other. So as the fluid moves up, it compresses, right? How many of you have ever seen how an Archimedes screw works? An Archimedes screw. What it used to be is for, in ancient times, it was how they would draw water from one place to another. Because these, essentially it worked with hydraulics. It was some of the basic early hydraulics. So you would have a shaft. I'm sorry, that is terrible drawing. You would have a very long shaft, and in it you would have a screw that as it would turn, your water is down here, and as it would turn, it would pull the water all the way up. Wasn't always the most efficient because they had no way to seal it, but at the same time, it got the job done. and you got water from down at the river to where your crops were. It's very clever engineering for it being ancient technology. Huh? Well, considering what it was, it's not exactly unadvanced. So,
Rotary screw compressors are also positive displacement machines. These compressors employ two rotating, interleaved helical
just for y'all
screws
to kind of
which
see how it
capture air
works.
in a pocket between them. The space
Like I
in which
said,
the
it
air is
gets
trapped
smaller as it
becomes
goes
smaller as it
up.
moves down the axis of the
It's
screw.
trapping the fluid
The
between the
compressed
two
air is
screws,
discharged from the opposite end of the intake.
and it
Rotating
compresses
screw
as it
compressors
goes.
can be used in applications ranging from
Does
3
that make
horsepower
sense?
to over 500 horsepower. They are
Sometimes a
commonly
video can be
used by
worth 1,000
roadside
words.
repair crews to power air tools and are also used for automobile engine superchargers.
Okay. And then you have lobe compressors. This one does not have a video. But it works similar to the screw, because what it's going to do is what? As it moves up, you compress it, and it just keeps rolling through the compression. Liquid ring, it goes between 15 and 300. It has a limitation of 15 psi at 300 cubic feet per minute, or 100 psi at 30 cubic feet per minute. It's not one of the more common ones. Diaphragm compressors, these are very common. They're little tiny compressors, much like you would use for your car. Axial flow or centrifugal force, which, how many of you have ever been in one of those centrifugal force rides where they throw you, or it throws you against the wall, and you actually ride it and continue, it spins you really, really hard and fast to the point where it actually starts lifting you off the ground. I've never been in one of those. There's one at the Space and Rocket Center. There used to be. Yeah. Basically, what you do is you strap yourself in, and this thing starts spinning, spinning, spinning. It just, well, you wear a safety harness in the one I used to be in, but yeah. So, centrifugal force spinning you completely until it gets to the end. By the time you get out of a centrifugal force machine, it tends to make you a little dizzy. You better not have inner ear problems when you go in. Impeller centrifugal, same thing. It's just spinning it really hard. How many of you ever seen the centrifugal force experiment with a bucket, where somebody takes a bucket full of water and they start spinning it around themselves and the water never comes out? Why? Because the force of the spin is actually holding the fluid into the bucket. Y'all have never seriously seen that? Coolest experiment ever. It's not one I would try unless you are sure you can get a lot of spin and force on that, because otherwise you will end up wet. So this is a multi-stage centrifugal. Like I said, it literally spins it through. Basically, I know one you might know of, the centrifugal force of your dryer and your washing machine. Why do you think the clothes stick to the outsides of the washing machine? Because when it's spinning it, it forces it out. And same thing for your dryer. As it's spinning it, essentially what your washer does is it's a giant one of these. Because as it spins it, what it's trying to do is it's trying to pull the water. So water is heavier than your clothing on a normal day, right? Generally, yes. So what it's doing is as it spins it, the water is being pulled to the outside and pulled outside the main drum. Does that make sense? So it's not creating a vacuum, it's just using centrifugal force principles to force everything heavy outside that drum. That's why if you've ever pulled your clothes out of the washer, generally they are stuck to the sides of the washer, yeah? And if you pull them out, they've got the little bumps and stuff from the washer. That's why, because it's literally using the centrifugal force to suck the water out. And now you know how that works. The same thing works for your dryer. Essentially all it's doing is blowing hot air on centrifugal force and forcing your clothes to dry. But it does it at a much slower speed, because if you've ever seen your dryer run, it tends to go a lot slower. You have all of these are just different types of compressors. This one is a scroll compressor, as you can see by the animation how it works. The fluid enters one way and it just keeps moving through. This one's a different type, it's a screw type. So the difference between a pump and compressor symbol versus a motor symbol is what? The direction of that triangle. Okay, if it's a pump or compressor, it's going to face out. If it's a motor, which way does it face? Inward. Think about how they work differently. A pump and compressor are pushing fluid into the system, yeah? That makes sense? A motor is pulling fluid from the system to run. That make sense to you all? Maybe one day instead of gasoline-powered vehicles, we could have fluid-powered vehicles. All you'd have to do is change the oil every now and then. That'd be kind of cool, right? All you gotta do is check your compression every now and then. Yeah, I gotta go get my oil changed Friday. Owner's manual for, no, I'm sorry, we'll kind of skip over some of this. This one is talking about different tank models and such. Again, it's all about what you physically need for the job, right? These are just some different ways of, whenever you go buy these, this is what you're going to be looking at. What is your lubrication type? Does it require oil or no? What is the operating noise level? Well, that's something else you've got to consider with any and all mechanicals, right? Why? Well, somebody tell me, at what volume does human hearing become damaged? At what decibel level? Anybody remember? Anybody want to look it up real quick? What is the decibel level at which you experience hearing loss? I figured. 70.
Noise above 70 dB over a prolonged period of time, they start to damage your hearing.
Which is why most noise levels, if it's over 70, you're supposed to be wearing what? Hearing protection of some sort, yeah? That's why a lot of the old people that go and work in these places, you come up to them and you don't talk loud enough, what do they sit there and do? That was awesome. Got two people saying the huh at one time. But that's true. Honestly, it is well known and well documented that a lot of these people that have worked forever in industrial places have a lot of hearing damage. Why? Because a lot of the noise by a lot of the older machines are above the level at which hearing damage will occur. Would cause hearing loss if you were operating next to it too frequently. Yes. So that is always something to consider, right? Especially in today's regulation heavy environment, is what is the decibel level? But it also depends upon how close are you working with this thing, right? Am I right next to it, or is this thing across the shop in a closet where nobody bothers it unless they've got to go do maintenance on it? And that's the one thing where if you're having to go into the closet and do maintenance on it, you might want to carry some hearing protection. Try having an office right next to the one in Ethel Hall. You think being in class with that thing is loud? Try being in a closed office next to it. All right, so cooling. As gases compress or generate pressure, they heat. So we have different ways to cool it with air cooling, liquid cooling, intercooling, aftercooling. I've already talked about some of this. Filters. Filters are a big thing, right? Filters are something you want to be very aware of, because if you've ever seen the air filter in your house and it gets nasty after what, a month or 3 months, that's where you might want to pay more attention to the filter on your compressor. Why? Because that thing's probably even nastier. Because we generally don't keep those in the house where we try and be very clean and not as dirty. It's out in a dirty, nasty shop all day, sucking in nasty dirt. Might want to change that a little more frequently. This is some after coolers. Again, that's, everybody's already hot and mad at each other in the room, so you turn on the AC. Versus cranking the AC. If you've ever been into a movie theater where they're anticipating a bunch of people at once, generally what have they done? They've cranked that AC up and you are freezing the entire time if there's not enough people in there. You have your receiver or tank. Piping is a must. Like I said, I'm trying to get through some of this real fast. Okay. So we're going to go ahead and take a break. Sound good? I'm going to take a break and let y'all get up, move around, and go ahead and